Welcome to the fourth and last part of training on Module B of the G.EN.ESI project. Module A of this video series gives you an introduction to the two fundamental concepts of eco-design, lifecycle thinking and environmental assessment. Module B will provide you with a detailed procedure to model the product lifecycle and perform an environmental assessment. This fourth part of Module B will focus on the final phase of product lifecycle, use and end of life. Those two phases dominate the environmental impact of a lot of electronic products. This video has been developed within the framework of the G.EN.ESI project, which aims to support the integration of eco-design within the design and development process through the development of a methodology and a software platform. The methodology is presented in Module C and the platform and tools in Module D. This research project started in 2012 and involves 8 partners, 3 from academia, University of Bath, University Politecnica del Marche and Grenoble INP, 1 public institution, the ENEA, National Agency for New Technology, Energy and Sustainable Economic Development, as well as 4 industrial partners, Grunta Design, Sibu Environment, Faber and Bungle Friuli Vectra. It is co-financed by the European Commission. The use phase is central to the environmental performance of any product which requires consumables, energy, water, materials, spare parts during the use phase. The use phase also has an important influence on the prior phase, as the act of purchasing the product occurs at the beginning of the use phase. The end-of-life phase is also dependent on the use phase, as it is influenced by the user approach to decommissioning. If we look at the environmental profile of true electronic product, we can see that use is by far the phase with the greatest impact. But what is actually happening during use? There are many different activities which occurs during use. The drivers for consumer behavior are tied to social practices and individual habits which the product itself can have very little influence upon. The following activities should be considered when analyzing product use: purchase, the activation or installation of the product, the actual use, the maintenance and repair, and the decommissioning of the product. When considering an electronic product that consumes paper and ink, such as a printer, we found that paper is the main contributor to the environmental indicators. When the 3 elements of the use phase are combined, paper, channel, and energy accounts for 94% of the environmental impact. Lexmark worked on improving the parameters which they have control over, adding a sleep mode to improve energy consumption and to improve cartridge life, an ink-saving mode and high-yield cartridge. Nevertheless, they still have little control on paper consumption, which depends entirely on user choices. To encourage the user to consider recycled paper, they ran a variety of tests which recycle paper to show that the use of the paper alternative with a lower environmental impact would not damage the printer. Energy efficiency is key for eco-design. The design for energy efficiency software can support you in improving your product by decreasing energy demand. It is available from UniVPM. Another strategy which can be applied to a product which use consumable is to design the consumable to be reused after a maintenance step. For the example of a copier printer, new packaging was developed to encourage the user to send back their used fuser. As part of the aim of eco-design, the packaging was designed to be reused and was made of recyclable material. The foam container was designed to example. After use, the product enters the final phase of its life cycle, end of life. Considering end of life during design is crucial because the product shape, material composition and structure have a major influence on the performance of end of life. There are 3 ways to recover a product at its end of life in order to close the loop of product life cycle. The most common strategy is recycling. Recycling is about recovering the material content of a product and to use it as a substitute for raw material in the first life cycle stage of another product. This is an efficient strategy, but to be more environmentally efficient, Two further strategies are worth considering: reuse and remanufacturing. To reuse a product means that you bypass the first two steps of the product life cycle by delivering the product directly to the distribution network. The second-hand market is an example of products that are shipped directly to distribution. Remanufacturing is a strategy that delivers the product to the manufacturing process for further work in order to be able to resell it on the market. Remanufacturing a product is about rebuilding a product from an older version and improving its performance. The first part of remanufacturing is the disassembly of the product. Step 2 and 3 are about assessing the ability of the component parts to be reused and repaired for a second life. The parts are cleaned, inspected, and classified as usable to be discarded or to be discarded. The usable parts are then refurbished and assembled together with any required new parts in order to have a fully functioning product. Remanufacturing is helpful to reduce impacts on energy consumption, material consumption, and waste. It also increases the product life cycle by making it usable several times. It's helping to recover the product's added value acquired during the design and the manufacturing process. It decreases prices. It helps meeting legislative requirements. It also decreases costs of landfill, for example. It creates jobs. It gives feedback to designers on how they should improve their product, and it gives a control on the second-hand market for your product. This mining truck has been remanufactured. This is an example of a second life for a complicated product such as a mining truck. This video is the final part of Module B on product life cycle. Module C will be targeted at the design process and how you can improve product design for the environment in practice.